Aloha, my name is Chatham Callan and I'll be reporting on this project entitled Regional Biosecurity, Operational Biosecurity, and Diagnostic Surveillance. This is the Operational Biosecurity section. I'd like to acknowledge the other participants in this project, primarily Dr. Charles Laidley, who is actually the project PI for the first year's activities, Kim Pinkerton and Eric Martinson, who are both research associates in the Finfish program. The overall goal of this project was to continue the expansion and diversification of Hawaii and the Pacific aquaculture industries, and a major constraint in achieving that goal was threats posed by various pathogens that could cause catastrophic losses in both vertebrate and invertebrate production systems. So the project was actually organized into two key priority areas: the operational biosecurity procedures for prevention of diseases, and that portion was conducted by our research group at Oceanic Institute, as well as the development of improved diagnostics and surveillance capability in the region, which was conducted by the University of Hawaii State Aquaculture Development Program. This report provides an overview of the activities under the operational biosecurity objectives, which was completed by Oceanic Institute. The project work included examining the makeup of the Hawaii aquaculture industry, reviewing each of the active sectors, developing a survey plan for biosecurity assessments, and meeting with a range of stakeholders in each of the sectors to provide these biosecurity assessments. It's important to point out that these projects, both components of these projects were conceived out of broad industry input and these two stakeholder meetings. The first workshop was held at the Windward Community College on the island of Oahu, and the second workshop was held at the Natural Energy Laboratory of Hawaii in Kona. And it was out of these two workshops combined that the objectives for this biosecurity project were devised and agreed upon. As I mentioned earlier, this project is actually divided into two components, and the regional biosecurity diagnostic surveillance component was actually done by Dr. Clyde Tomorrow and his colleagues at the University of Hawaii Sitar. And that portion focused primarily on emerging disease of concern with tilapia. And Dr. Tomorrow put together his project report at this web link below. You can watch a video of that presentation. I'd also direct you to the publication that came out of that report by Klinger-Bowen et al. 2012, published by the Center for Tropical and Subtropical Aquaculture. So the objectives of this portion of the project, being a two-year project, were as follows. In the first year, we wanted to develop a general aquaculture biosecurity plan for Hawaii and the Pacific region. This involved making a survey plan for reviewing the biosecurity procedures currently in operation, and also to conduct biosecurity assessments of these operations. In year two, we then wanted to take that information and make specific biosecurity plans for the major culture species and farm operators. That year had three objectives. The first one was to complete the specific assessments from each farm. The next objective was to write a report reviewing these species-specific biosecurity operating procedures. And then the last one was to convene a workshop reviewing these evaluations and facilitating further discussion. So the first objective in year one was to develop this survey plan for reviewing operational biosecurity for aquaculture operations in the Pacific region. The first task was to assemble lists and contact information for aquaculture producers and other stakeholders, which surprisingly had not been done up until this time. So with the assistance of the State Hawaii Department of Agriculture, we compiled a list of 58 aquaculture producers, and then we sorted that data by island so we could look at the makeup of the state's aquaculture industry. You can see here briefly there were 26 companies listed on Oahu, 23 on Hawaii, and 3 on each of the other 3 main Hawaiian islands. On Oahu, most of the industry is represented by educational or research institutions, several marine ornamental import or export operations, along with some small ornamental producers, hatchery and grow-out operations for shrimp, also several species of freshwater fish, including tilapia and koi. There was a large-scale marine fish farm producing moi which is currently on hiatus. However, there's another company looking to take that operation over. There's also several emerging aquaponics operations that mostly focus on plant production, but they do use fish in their production units, mostly tilapia. On the island of Hawaii, most of the aquaculture is conducted in the Natural Energy Laboratory north of Kona, which basically houses various aquaculture operations. The most dominant there are the microalgae producers, which produce microalgae for the dietary supplement industry. There's also a large desalinated saltwater bottling operation. It's also home to a growing diversity of aquaculture farms that produce finfish like amberjack, flounder, cod, moi, tuna, several shrimp hatchery and breeding operations producing SPF shrimp, as well as different bivalve operations culturing oysters, abalone, and clams. It's also home to some lobster holding and crab holding and conditioning, as well as some marine ornamental producers that are producing things like seahorses and giant clams and other ornamental invertebrates. There's also some operations on the other side of the island over in Hilo at the University of Hawaii at Hilo, primarily aquaponics and tilapia, as well as freshwater ornamentals and sturgeon. On the island of Kauai, currently has operations producing shrimp, tilapia, and aquaponics. Similar on Maui, where primarily it's focused on aquaponics, producing plants and freshwater ornamentals. And the island of Molokai has operations producing shrimp, live rock, and has people investigating use for Hawaiian fish ponds. This table just shows the complete breakdown of all of the companies that we were able to locate with the help of the State Department of Agriculture. We sorted the companies by island, and then location on each island, and then by the products that they produce. And so as you can see, Hawaii and Oahu make up the bulk of the producers, with Kauai, Maui, and Molokai each having just a few aquaculture companies on each. This table shows just a further summary of the breakdown of the types of operations that are commonly being practiced in Hawaii. And you can see it's a pretty diverse array of farming activities, from algae production to aquaponics, aquarium displays, bivalves, other mollusks, crustaceans, primarily shrimp, with a recent focus on pathogen-free shrimp. It's both freshwater food fish and freshwater ornamentals, Hawaiian fish ponds, which right now are being used mainly for educational and cultural activities. However, there is recent interest in revitalizing these ponds for fish production. There's also marine ornamental interests in import as well as export of organisms, which are primarily wild collected. However, there are culture activities underway to culture these organisms. There's one facility in particular on the Big Island doing seahorses. There are R&D organizations such as Oceanic Institute and University of Hawaii, which have a diverse array of species for different purposes, as well as the seafood import and export companies, which are, although they're not culturing animals, are still of interest from a biosecurity perspective because of the possible spread of pathogens. This figure just shows the breakdown of the various aquaculture sectors in Hawaii by value. And you can see the total value was estimated about $30 million in 2010 from the National Agricultural Statistics Service. The bulk of this is comprised by algae, which has the highest market value, followed by the other sectors you see here. The next part of this objective was to develop a survey plan. And in order to get a better understanding of the present aquaculture biosecurity practices, we had to develop a survey plan to look at the biosecurity operations across the region. Biosecurity is defined as the suite of procedures that protect living organisms from contracting, carrying, and spreading pathogens and other non-desirable organisms. And it's classically divided into a series of functional steps, starting with hazard identification. And this flow diagram will outline these steps and procedures in typically evaluating biosecurity. Hazard identification is basically the identification of all known pathogens in a particular species or region. Risk assessment examines the risk of introduction and risk establishment of these hazards. So the next activity under this project was to develop this survey plan specifically tailored to examine and review the present day-to-day biosecurity concerns and practices so i.e. the risk analysis for the key players in Hawaii and the associated animal producers. Risk analysis entails the identification of all known identifiable pathogens in a particular species of regions. Risk assessment examines the risk of introduction and the risk of establishment of these hazards. Key issues that we had to consider were the examination of the stock origin, the method of stock collection, quarantine protocols, water source and treatment, water quality monitoring, air treatment, the health expertise of the staff, preventative treatment and vaccination and practices, chemical use for disease control, prophylactic and therapeutic treatments, disinfection and cleaning protocols, as well as the import and export information, how the organisms are disposed of, the history of the stocks, and the record keeping. Taking all of these things into consideration, we basically developed a survey plan, which you can see here, where we formed the basis to answer these questions on the site assessments of aquaculture operations in Hawaii. So this survey plan was further refined while conducting the assessments and has been made available to the industry stakeholders as part of this report. You can see here these questionnaires were distributed and filled out during our site visits, and where we would gain information about the number of types of species, the importation of the species, if there were quarantine protocols, what type of disease treatments, what types of disease concerns the stakeholder had, how they got their water and how they treated their water, what type of water quality monitoring they did, what type of disposal they had in place, as well as where the air source came from and their cleaning and disinfection protocols, as well as any mortality information. So all of this information was compiled at each of these stakeholders' visits so that we could better assess how biosecurity practices were being implemented at each site. So the next objective was to complete a general biosecurity assessment of aquaculture operations in Hawaii. So using the survey plan and procedures developed under Objective 1, we had 20 stakeholders representing the various sectors across the state that participated in the general assessments. During these assessments, we identified the major vectors for pathogen entry and spread, both within and between the stakeholder facilities. Primarily, these were the water source, water disposal, the source of the culture organisms, air source, food source, cleaning protocols, and disease screening. After completing these assessments, we then identified the primary diseases of concern for each of the sectors. This table just identifies some of the diseases of concern in the marine fish and freshwater fish sectors. However, similar tables were compiled for the shellfish, algae, and other sectors, and those are available in the written report. Under year 2, we basically were going to continue our site assessments, and the first objective was to develop specific biosecurity plans for these major culture species. So now that we had a general assessment of the Hawaii aquaculture industry, which was done under year 1, and a survey plan that was executed, we continued to use these surveys to work on specific sectors and specific farm operators. So an additional 10 stakeholders on the islands of Hawaii, Oahu, Kauai, and Maui were surveyed for this purpose. And we did, during this time, observe many general trends across the sectors that could be used to make overall observations and recommendations on biosecurity for these sectors. It should be noted, while the original intention was to utilize the results of these in the previous year's surveys to develop a series of recommended biosecurity operating protocols for each of the sectors, we were unable to do that. The reason for this is that during the assessments, it became clear that the stakeholders did not wish to participate at that level, and in fact, many of the participating stakeholders specifically asked that we did not include their specific information on biosecurity practices or even their company's names in any subsequent reports. Despite our assurance that the survey data would be kept anonymous, nearly all the stakeholders surveyed were reluctant to participate at the level necessary to assist us in drafting the recommended operating protocols for their specific sector. Reasons for this included growing concern that this information could be taken out of context and possibly utilized to assist those in opposition of aquaculture. For example, if we were to identify a particular weakness in biosecurity practices in one sector and make recommendations to improve those practices, there was a concern that those recommendations could become requirements, further restricting the expansion of the industry. An equally relevant concern among stakeholders was that this topic could be misconstrued among those not familiar with the overall concept and might cast a negative perception on the industry in general. So while the collected data could not be used to create sector-specific assessments, we were able to observe general trends across sectors that could be used to make some overall observations and recommendations on operational biosecurity. The first of these, principles or protocols related to the practices of biosecurity, we found that most facilities had limiting access to their facilities, they had routine monitoring of animal health, and they used barriers to prevent entry of spread of known pathogens, and most practiced excellent site hygiene in order to keep their facilities clean and healthy. Also, it was important to notice that biosecurity practices were obviously most established and most strictly applied in sectors where disease had already been identified as a significant threat. And this is primarily in the shrimp and shellfish sectors, where known pathogens and known diseases already exist and can be excluded through biosecure practices. However, some of the practices implemented by the shrimp and shellfish sectors could be applied to other sectors, and these are improved quarantine of newly acquired stocks, limiting the importation of new stocks to established sites, development of improved hygiene, meticulous record keeping, and rapid response to emerging threats. During our site assessments, we also visited with the Natural Energy Laboratory of Hawaii Authority staff. This organization has invested significant time and resources into the development of their aquatic species health management plan. It's important to note that this plan is available by written request to the NELHA organization. And this plan outlines really good biosecure practices that could be implemented by any of the sectors to the benefit of their biosecure operations. This organization, as well as its tenants, is being placed under increased scrutiny by those that are opposed to further aquaculture development. And it's important to note that this is one of the reasons this project's objective of conducting specific assessments or generating specific assessments for each sector was so hard to accomplish, is due to this increasing awareness of negative attention on aquaculture, and people are getting increasingly cautious about what information they share. The staff at the Natural Energy Laboratory of Hawaii was kind enough to provide a written transcript of my meeting, as well as the answers to my questions, and this transcript is made available as part of the written report that accompanies this presentation. The next objective under year 2 was to write a project report for reviewing species-specific operational biosecurity for specific farm operations in Hawaii and the Pacific. Now, as explained earlier, we were unable to provide these species-specific or sector-specific protocol reviews, largely due to the inability to recruit that information from the stakeholders. However, what we were able to do was to provide a valuable overview of the Hawaii aquaculture industry, the existing biosecure practices, and common concerns of the major sectors. We also highlighted the need for enhanced communication between the stakeholders and policymakers regarding the future development of the industry. The last objective was to convene biosecurity workshops reviewing the evaluations and facilitating further discussions on aquaculture biosecurity and the future needs in the islands. It was determined during the stakeholder visits that the majority of the interested parties would be unable to attend a workshop, particularly if they needed to travel inter-island. So instead, most of the stakeholders that were interested in this information asked that we make it available online so that interested parties could access it at their convenience. And so this objective is being fulfilled via this narrated PowerPoint presentation and link to the written report that can be obtained at the CTSA website. The expected impacts from this project were that the information gathered under this project provided valuable assessment of the state of the industry of the Hawaii aquaculture industry. Up until now, this assessment had not really been made, and so now we have a much better understanding of what aquaculture practices are underway here in Hawaii and what level of biosecurity each of these incorporate into their day-to-day activities. So what it can be used for is to help review the existing practices identify potential weaknesses, and provide insights facilitating the development of effective pathogen control strategies for the region in the future. Recommended follow-up activities. Unfortunately, because many of the current stakeholders were unable or unwilling to participate at the level required to systematically review their protocols and make species-specific or sector-specific recommendations, we need to still have that as an objective for the future. Also, I think further investigation and discussion on the public perception of aquaculture and its effects on the aquaculture industry of the island should be addressed. Due to the increased scrutiny being placed on aquaculture and the practices here, it's likely that this type of stakeholder input will be limited until we can figure out a better way to increase communication and streamline this process. I'd like to thank you for listening to this presentation. If anyone would like more information or a written copy of the project report, you can go to www.ctsa.org for more information. Mahalo.